You know, we're standing right at the edge of a technological shift. And this one is so profound, it's not just about our devices, it's about redefining human communication itself. We're about to step into what's being called the post-linguistic era. So let me just ask you this. What if language, as we know it, became obsolete? I mean, what if you could just transmit an idea, a feeling, a concept directly from your mind to someone else's, or to a machine? This isn't science fiction anymore. This is the very near future that we're going to break down. To really get your head around this, think about the jump from that old dial-up internet screech to fiber optics. That's the scale of change we're talking about here. We're moving away from the slow, clumsy mechanics of making sounds with our mouths to the instantaneous transmission of pure thought, of raw intent. So, why do we even need this monumental leap? Well, it all comes down to a fundamental problem that's hard-coded right into our own biology. It's called the bandwidth bottleneck. Think about it. Our brains are these incredible supercomputers, processing so much information all at once. But for all of human history, that amazing processing power has been stuck in traffic. We have to squeeze these huge, complex thoughts through the tiny, slow process of moving our thumbs on a screen, or coordinating our tongue and our jaw just to speak. And researchers have actually put a number on this. You can think of it as the refresh rate for your conscious mind. And it's shockingly slow. No matter what we're doing, our brain's real-world output, the speed at which we can consciously handle new information, tops out at about 10 bits per second. That's not a limit of our fingers or our mouths. That's a fundamental speed limit of our own consciousness. Okay, so this chart just lays the whole problem out in black and white. Look at this. Our fastest traditional method, speaking, clocks in at around 13 bits per second. It's just barely keeping up with that cognitive speed limit we just talked about. Typing, way slower, less than half that speed. And this shows us something really, really important. Even a perfect futuristic brain implant can't make you think any faster than that 10 bits per second limit. The bottleneck isn't the interface, it's us. So the goal isn't to think faster, it's to communicate at the actual speed of thought. So if the problem is this biological traffic jam, what's the solution? Well, this is where it's really interesting. Let's talk about the emerging tech stack that promises to finally blow this bottleneck wide open. The key technology here is the Silent Speech Interface, or SSI. These are wearable devices that can communicate without you ever making a sound. How? They decode the tiny silent signals your brain sends to your speech muscles when you're just thinking about talking. You know that little voice inside your head? It basically learns to read that. Now, there are two main ways companies are trying to do this without, drilling into your skull. On one hand, you have EEG, which tries to read brain waves directly. The problem is our skull and scalp muffle those signals, making them really noisy. That's why EMG is really leading the way right now. Systems like Alter Ego use EMG to read the super clean electrical signals from your facial muscles. And here's the crucial part. They only pick up on signals when you intend to speak. That distinction is going to become a really big deal when we talk about privacy. But believe me, this field is absolutely exploding. It's a technological gold rush. Researchers are playing with everything, from super thin strain gauges that feel skin movement to radar systems that measure your face without even touching it. They're all in a race to build that perfect, seamless interface. And this isn't happening in some far-off future. This is happening now, and it's happening fast. By 2025, we're going to see the first of these devices for sale. By 2027, you can expect to see discrete AI-powered wearables. Think silent speech necklaces. And by 2030, we'll probably be seeing the first prototypes that try to go even deeper, moving beyond muscle signals to try and capture a thought before it even becomes a word. The momentum is just undeniable. But as we get ready to unlock all this potential, we are also unlocking a whole new level of risk. This incredible new power comes with a huge societal cost, forcing us to face what could easily become the ultimate privacy nightmare. This quote really gets right to the heart of it. We are not talking about your search history or your GPS data anymore. We are talking about the raw, unfiltered electrical patterns of your mind. There is literally nothing more personal than that. Let's just put this into perspective. Right now, with an encrypted chat, the content of what you're saying is protected. But with raw neural data, by default, it protects nothing. It doesn't just expose your silent speech. It can expose the very building blocks of your thoughts, your intentions before you act, your emotional state, your unique cognitive patterns. This just opens a total Pandora's box of really unsettling questions. I mean, who owns your thought patterns? Could an advertiser target you based on a passing desire, something you haven't even acted on yet? What happens when this data can be subpoenaed in court? Or worse, stolen? Some analysts are even warning about a future of remote neural monitoring, where someone could potentially spy on or even influence your mind from a distance. Okay, so what does this all add up to? If we look past the incredible promise and the terrifying peril, what does daily life actually look like in a world where this technology is everywhere? So in this future, we're not just going to be silently talking to our devices. We are going to be part of a vast network, an internet of thoughts. This network will let us transmit whole concepts. Imagine an architect being able to send the entire vision for a building, not a file, not a drawing, but the idea itself directly into the minds of her engineering team. That's synthetic telepathy. You can really see this as the next logical step, maybe the final step in our evolution with hardware. We went from interacting with phones in our hands to interacting with AR glasses with our eyes. Now we're entering the cognitive era, where the interface itself just disappears. It becomes our thoughts, translated by these discrete wearable sensors. The impacts on society are just going to be staggering. On one hand, you have the beautiful utopian vision, giving a voice back to people silenced by diseases like ALS, or a team of firefighters sharing a silent, real-time map of a burning building in their minds. But all of that potential is balanced on a knife's edge, with the absolute urgent need for a new legal framework of neuro rights to protect our most basic freedom, the freedom of thought. And all of this leaves us with one last, really profound question. As we move from an internet of computers to an internet of minds, when our thoughts become nodes in a network, the very definition of what it means to be an individual is going to be challenged. What is a singular self when our minds are all connected? That is the question that's going to define the next decade.